All right, so today we're going to take a look at section 8.2, which is law of sines, and technically this is day 1. All right, so taking a look at the triangle below, the directions say solve the following using SOHCAHTOA. All right, so we have a small problem here though, because if I take the two angles, the 45 and the 40, subtract those from 180, we've got a 95-degree triangle. Okay, so SOHCAHTOA can only be used if there is a right triangle, and in this case, it's not a right triangle. So technically, the directions here do not allow you to solve using SOHCAHTOA. So again, in order to use SOHCAHTOA like we did in the last section, you must have a right triangle. All right, so we're going to take a look at what is called the law of sines. Okay, so some of you may have seen this before. If we have a triangle that's not a right triangle, again, this is angle A. The side opposite is side A, which is the lowercase a. Here's angle B. Opposite that is lowercase b. Here's angle C. Opposite that is lowercase c. So always the sides opposite those angles are represented with the lowercase letter of the same. All right, notice that I have the altitude drawn in here, or the height, so I'm going to call that H for height. Okay, so we do have a right triangle here. So if I look at the triangle here on the left side, I can come up with the sine of angle A is the opposite side, which is H, over the hypotenuse, which in this case is C. If I multiply both sides by C, I can solve for the height, and it's going to be C times the sine of angle A. Now, if I take a look at the triangle on the right, so I look at the bigger triangle, we can do the same thing here, and if I take angle C, I can say that the sine of angle C is equal to the opposite, which is H, over the hypotenuse, which is A. And just like I did on the last one, if I multiply both sides by letter A, I know that the height is equal to A times sine of C. Well, the one thing we do know from this triangle is that the heights are the same, right? Because they represent that same piece right there, the altitude of that triangle. So using substitution, I can take out this H right here and plug in what H is equal to. Okay, so that gives me C times sine of A is equal to A times sine of C. Okay, if I go to solve this, or not solve this, if I try to, if I divide both sides by C, and if I also divide both sides by A, notice here the C's reduce, the A's reduce, and I come up with sine of A over lowercase a equals sine of C over little c, okay? And then that actually gets me to the law of sines, and I could apply this too. If I switch this and if I called this angle B, I could do the same thing, and that shows the law of sines, which is sine of A over lowercase a, sine of C over lowercase c like I just proved, and then sine of B over lowercase b. So this works for triangles that we cannot use SOHCAHTOA for, so it gives us another alternative. All right, we are going to talk tomorrow about what is called the ambiguous case. And the ambiguous case happens when we're given two sides and an angle, so side-side angle. There's three possibilities. When we take a look at law of sines, there is a possibility that no triangle can be formed, which we're going to take a look at today. There's a possibility that only one triangle can be formed, and that occurs when the second triangle doesn't add up to 180 degrees, or it's too big. And then also tomorrow we're going to take a look at what happens when when can we form two triangles. Okay, so again, that's when you're given two sides and one angle. Today we're going to look a little bit more at what happens if I give you two angles and only one side. All right, so let's take a look at the first triangle. So it says, can we solve this triangle with what we know now? Okay, so again, the ambiguous case uses side-side angle, but if we look, notice we have two angles. So in this case, it is not going to be the ambiguous case, so we can say no, because of the fact that we were given two of the angles. Okay, this was actually the triangle that we started with in the beginning of today's notes. So the nice thing is to find angle C, that's actually pretty easy because we were given two of the triangles. So if I subtract those from 180, that gives me 95 degrees. Okay, now I always talk about when we use law of sines that we want a full fraction. So that means I need to know an angle as well as its opposite side. So in this case, I do not know what little b is. If I use the 45-degree angle or angle A, I don't know what little a is. But I do have a full fraction when using the law of sines. I know angle C and I know side C, right? Side C is 95. So what we're going to do first, and I'm just going to decide to solve for side A first because that's what was written first on the side, but it really doesn't matter. I'm going to use that full fraction. So we've got sine A over A equals sine B over B, and then sine C over little c. And again, we can fill out this fraction right here. So I know that sine of 95 over 4, right? That's sine of C over C. And if we're going to look for little a, I've got to use this part right here. So it's sine of angle A, and we know that angle A is 45 over lowercase a. Okay, so all we have to do here is cross multiply. So I get a times sine of 95 equals 4 times sine of 45. And then I just have to divide both sides by sine of 95. Okay, when we plug that into our calculator, please make sure that you close the parentheses. So I have to do 4 times sine of 45. Either hit enter or make sure you close the parentheses and divide by sine of 95. If I'm going to round to 2 decimal places, that gives me a value for a of approximately 2.84. So I know that a is approximately 2.84 if we round to the nearest hundredth. Now we're going to do the same thing and we're going to solve for side B. Okay, so again, I'm going to take that full fraction that I was given. So that's sine of 95 over 4. But this time I'm going to use sine of B over B. So it's sine of 40 over lowercase b. And then we cross multiply. So it's b times sine of 95 equals 4 times sine of 40. Again, divide both sides by sine of 95. So that gives me b is equal to 4 times sine of 40 over sine of 95. And again, be careful if you're going to do it all in one. Make sure you close that parenthesis after the 40. So you do 4 times sine of 40. Close your parenthesis or hit enter and then divide by sine of 95 and you should get b is approximately equal to 2.58. Okay, so there I solved the entire triangle. I found the missing angle, which was 95, and the two sides, which were 2.84 and 2.58. Okay, and again, we know it wasn't the ambiguous case. There can't be a separate triangle because we were not given side-side angle. We knew 2 of the angles, so there was only one option for that third angle. Okay, again, we can't use SOHCAHTOA here because this wasn't a right triangle. We also can't use Pythagorean theorem to find that third side. Some of you may have been questioning that. But again, you can only use Pythagorean theorem and SOHCAHTOA when it's a right triangle. All right, so let's take a look at this triangle. All right, so the first thing we have to ask ourselves is it ambiguous? Do we know side-side angle? Okay, right now I have 2 sides and we have an angle, so yes, this is the ambiguous case. So right now, when I go to solve this, okay, I do have a full fraction here, right? I've got angle A and side A. So I could do sine of 60 over 4 equals sine of B over 5. Okay, when I cross multiply, I get 5 times sine of 60 equals 4 times sine of B. When I divide both sides by 4, that gives me sine of B is equal to, and if I go to my calculator and I type in 5 times sine of 60, hit enter, divide by 4, that gives me 1.08. So here we have a small problem. Hopefully remember this from previous solving equations. Sine, we know sine has to be between -1 and 1. Well, right now we're looking for a sine value that's 1.08. So if I go to my calculator and I do second sine of that answer, it gives me an error. So in this case, there is no triangle possible. Okay, so yes, it was the ambiguous case, which we'll talk a lot more about tomorrow because I knew 2 sides and an angle. However, in this case, because sine was more than 1, this is not a possible triangle. All right, here is another example. We've got a triangle with angles 40, 60, and then a side A of 4. So is it ambiguous? Is it side-side angle? We can say no, it's not. So we can go ahead and solve this triangle. Okay, so again, to find angle C is going to be 80 degrees because I know all those angles have to add up to 180. So 60 and 40 is 100. Subtract that from 180, that gives me 80 degrees. Okay, across from angle A is side A, across from angle B is side B, and across from angle C is side C. Okay, so again, we are looking for side B and side C. It doesn't matter which one you find first. I'm going to go ahead and find side B first. So again, it's sine of A over little a, sine of B over little b is equal to sine of C over little c. Okay, the full fraction that I know is I know angle A and side A. So I'm going to go ahead and do sine of 40 over 4. Let's find B first, so that means I'm going to use this piece right there. So that's going to be equal to sine of B, which is 60 over little b. Same idea, we're just going to cross multiply. So that gives me B times sine of 40 equals 4 times sine of 60. Divide both sides by sine of 40. So B is going to be equal to 4 times sine of 60 over sine of 40. Go to our calculators and type that in. So 4 times sine of 60, hit enter or close that parenthesis, and divide by sine of 40. That gives me 5.39. So side B is approximately 5.39. Again, that was a rounded value, so that's an approximate value for side B. Okay, now we're going to do the same thing, but this time we're going to use that same full fraction, sine A over A, but this time we're going to use sine C over C. So the left side's still going to be the same. Sine of 40 over 4 is equal to sine of C, which in this case is 80 over little c. Again, we've got a fraction equal to a fraction, so the best way to solve this is to cross multiply. So I get C times sine of 40, 4 times sine of 80, divide both sides by sine of 40. So C is equal to 4 times sine of 80 all over sine of 40. 40 right there was a little sloppy. All right, so I go to my calculator and I do 4 times sine of 80. Either hit enter or close the parentheses and then divide by sine of 40. So that gives me side C is equal to 6.13. So side C is 6.13. So now I have found all my missing parts and I have solved that triangle. All right, so let's take a look at some applications here. So problem 4 says, to measure the height of a mountain, a surveyor takes 2 sightings of the peak of the mountain at a distance 900 meters apart on a direct line to the mountain. So we have a picture down here. We've got a mountain that we're trying to measure how tall it is. And it says that it takes 2 sightings that are 900 meters apart. So I know the distance between these two is 900 meters. It says the first observation, so as he was walking away from the mountain, the first observation was an angle of 47 degrees. So we've got an angle of elevation right here of 47 degrees. And the second results an angle, the second one was an angle of 35. So that was 35 degrees. It says if the transit is 2 meters off the ground, so that means this height right here is 2 meters off the ground. So we're going to have to add that at the end to the height of the mountain. How tall is the mountain? So again, what we're looking for right here is the height. So we're just going to call that letter H. All right, so here's the problem. We have 2 separate triangles. We have this yellow triangle right here. And so far in that yellow triangle, all we know is the 47 degrees, and we know we're looking for the height. So unfortunately, we don't have enough information there. We do have a right angle here because we're going to assume that it was measured perpendicularly because that's how we find the height. All right, so we don't have any side lengths in that triangle. We just have the 3 angles. That's not going to allow us to use the law of sines to find any information. However, if we do look at this triangle over here on the far right, the far left, this orange triangle that I'm coloring in right now, that's not a 90 degree, that's not a right triangle. However, it is a triangle. And we know that This side length right here down on the bottom is 900. Okay, we also know some more information about that triangle, which we'll talk about in a second. So let's draw those two triangles. So again, I've got a little triangle going here, and then I also have this right triangle over there. So I'm just going to separate those two triangles. I've got the height, I've got 47 degrees, and that's all I know about the yellow triangle. But in the orange triangle, I know this is 900. I know this guy right here is 35 degrees. And I don't know if you've thought about it at all. We can actually find this angle here too. Because if you look at these two angles right here, those are supplementary. They add up to 180 because they form a straight line. So I know this angle right here is 133 degrees. Okay, if I find the other angle up at the top, subtract them from 180. So if I do 180 minus 35 minus 133, that gives us 12 degrees up there. So let's focus on this triangle on the left. Okay, so I do have a full fraction here. I know this is 12 degrees and I know this side is 900. Okay, so how is that going to help me? I know that sine of 12 over 900 is going to equal, and I can keep going there, but let's talk about what that triangle has in common with the other triangle. So if I look right here, notice that this piece right here is common in both triangles. It's this piece here on the far right, and it's also the hypotenuse of that other triangle. So if I were to able to find this measurement, I would be able to use SOHCAHTOA to figure out the height of that mountain. All right, so we need to find that purple piece. So if we call this angle A, we can call this side A. All right, so let's find side A. So I know if I were to complete this proportion here, sine of 12 over 900, that has to equal sine of 35 over little a. So if I cross multiply, that gives me A times sine of 12 equals 900 times sine of 35. Divide both sides by sine of 12. So that gives me A is equal to 900 times sine of 35 over sine of 12. So we go to our calculator, we type in 900 times sine of 35, hit enter or close your parentheses, divide by sine of 12. That gives me 2,483. I'm going to round to the nearest meter. That gives me 2,482. 2,483. So this piece is 2,483. So this piece over here is also 2,483. And again, if I asked you to round in the nearest hundredth, round in the nearest hundredth. We're going to round to the nearest whole number right now. All right, so now, like I mentioned, the triangle on the right is a right triangle. So we can go ahead and just use SOHCAHTOA. So if this is my angle, I know this is the opposite side, and this is across from the 90. So here's my hypotenuse. So I can go ahead and use sine, right? Opposite over hypotenuse is sine. So I can do sine of 47 degrees is equal to the height, or that opposite side, over the hypotenuse, which was 2,483. Multiply both sides by 2,483. And if I round to the nearest whole number, let's see, 2,483 times sine of 47, that gives me 1,816. And let's see, it was meters. Now the one problem we forgot though, that's this piece, that's this piece right here, but there was an extra 2 meters. Remember that that tower, or that transit, was 2 meters off the ground. So we really have to add 2 there. So the height is really 1,818 meters. Okay, and again, I just chose to round to the nearest whole meter. We could round lower if we wanted to. All right, last example for today. It says 2 observers that are 2.32 miles apart see a hot air balloon between them. So first of all, it tells us that they are 2.32 meters apart. It says person 1, so let's call this guy on the left person 1 and this on the right person 2. It says person 1 sees it at an angle of elevation, so we know this angle right here as he looks up or she looks up to the balloon is 28 degrees. And then person 2 sees it at 37 degrees. All right, so we want to find the height of the balloon. So we know that the height is always measured perpendicularly, so that gives us a right angle. But if you look at the triangles, you would think that we could go ahead and use SOHCAHTOA, but again, the triangle on the right, all we know is one of the angles. We don't know how big this side is. We just know that the whole thing is 2.32. And if you look at the triangle on the left, same thing. We only have that angle right there. We don't have any other measurements other than that 2.32 at the bottom. So in order to do this, we have to find one of the sides. Okay, it doesn't matter if we find the side on the left or the side on the right. I'm going to go ahead and call this X on the left-hand side, and we're going to find that side length first. Again, you could find this side if we call it Y. You could find that angle or that side length as well. Okay, but again, remember, we're trying to find the height there. But for right now, we're going to ignore the height. So I'm going to go ahead and erase this, and we're just going to look at that big triangle. So I do have two of the angles. I've got the two angles on the bottom. So if I subtract those from 180, I get 115 degrees up at the top. So if I'm first looking for X, I can go ahead and set up my triangle. I have a full fraction because I have that 115 and that 2.32 down at the bottom. So I know sine of 115 over 2.32. And again, we're going to look for X, so I'm going to get rid of Y. So that means I have to now use the other angle, which is 37, and the side opposite it, which is X. So it's going to be sine of 37 over X. Go ahead and cross multiply. I've got X times sine of 115 equals 2.32 times sine of 37. Divide both sides by sine of 115. And if I go to my calculator, I need to type in 2.32 times sine of 37 divided by sine of 115. And again, be careful with those parentheses. So 2.32 times sine of 37, close your parentheses or hit enter, and then divide by sine of 115. That gives me approximately a value of 1.54. I'm just going to round to the nearest hundredth. Okay, so that means I know this piece right here, which we called X, we know that piece is 1.54. So now I can go ahead and draw in the altitude. Okay, and I'm going to take that triangle to the left, and I know this is 90 degrees, this is 28 degrees, this piece is 1.54, and I want to now find the height. Again, because it's a right triangle, I can use SOHCAHTOA, only if it's a right triangle. I know I'm looking for the opposite side, and this is the hypotenuse, so I'm going to use sine. So it's sine of 28 equals h over 1.54, opposite over hypotenuse. To solve that, I just multiply both sides by 1.54. So to find the height of the hot air balloon, I've got to take 1.54, multiply by sine of 28, and I get 0.72 miles. Okay, so that hot air balloon is a little less than a mile above the ground. And again, I know it was miles because the units in the word problem was miles. So the height is approximately 0.72 miles. So again, I should make that approximately equal to, because it's not, or we had to round. All right, that is all for today.